And we're on. Hello, and may the 4th be with you. Star Wars Day. Got my Rogue One shirt on. Yeah. Okay, let's wrap up this chapter here, shall we? So we last left off with bioengineering. We looked at the idea of how we can work with processing food. We can deal with improving on animals, and we can make medicines and synthetic hormones and all that. Okay. But now we got to look at biomedical engineering. And that's what my friend does. Okay. Where you use support systems to identify diseases, physical mechanisms to help people. Biological engineering with human beings, medical technology. So if we look at it, the goal, if you look at for medicine, is to have longer, healthier lives through medicine, transplants, cell treatments, and that's where you get into things like genetic engineering, like pharmaceuticals and vaccines. Okay, monoclonal antibodies. Okay, so those are all things that are being involved with biological engineering with humans. So when we talk about monoclonal antibodies, we're talking about the idea that for certain viruses, they do have receptors. And that's when you guys have seen pictures of the coronavirus, you see these things that are sticking out. Okay, this whole thing is the virus. Okay, now those receptors you see there, okay, they're kind of specific and they will attach themselves to human cells and do bad things with it. That's another topic for another day. When we talk about the antibody that's there with the attached treatment, okay, that will either slow down or kill the virus. Okay, and that is at this date, May the 4th, 2020. That's what the doctors and scientists are trying to work on, something to take on the coronavirus, the COVID-19 virus. Okay. Genetic screenings. This is another one that we can have. Providing information about genetic makeup of individuals. Part of it is you can determine diseases that may be encountered or passed on. You can determine potential risks for genetic diseases in newborns. There's over 2,000 of these different types of genetic screenings that have been designed. So we can find out ahead of time if there's a chance that the child will be born with Down syndrome, for example. My friend, he has a son who has a very rare genetic disorder called propionic acidemia. And what this is that the ability to break down proteins doesn't exist. We don't have a problem with munching on a burger or cheese or something that's got a lot of protein in it, and our bodies will break it down. In the case of my friend's son, he doesn't. He can't. And they didn't know. It is a recessive, homozygous recessive. Okay, mom had it, dad had it. Nobody on either side of the family knew about it. When they had their son, he was having convulsions very early on, and they would take him to the hospital, and he had unbelievably high levels of ammonia in the bloodstream. And the thing is, by the time the doctors were able to figure it out, okay, the boy suffered brain damage. Okay, and that has affected him. At that time, because he is 29 now, the test had to be sent to the Netherlands or Holland for them to test. It was not here in the United States. Now, that has since changed about that. But they found out about it, propionic acidemia, and they had to change the diet. There were multiple trips to the hospital. Even with the change in diet, there were times he would have to go to the hospital because things would go wrong for him. He He is 29. He's probably got the mental age of maybe a 9 or a 10-year old. His growth is definitely stunted because he essentially can't have proteins, so that makes it very difficult. Um, the doctors had given up on him when he was a baby. The doctors had given up on him. But the family didn't. They worked with him, they loved him, and he beat the odds. Okay? And I can still picture him in my mind now for that. The impact of the genetic testing, I'm not going to go any further into my friend's history, but it did dictate other decisions for the future for them. But for this young man, um, he does not really swallow like you and I would swallow. I mean, he can drink liquids and maybe swallow a few pieces of bread, and that's about it. But he has to take his, he gets a hole in the stomach, okay? He has a hole in the stomach where they pump in this green liquid that has all the nutrients that he would need, okay, so that he can survive. The reality is, for him, it is said that the condition will eventually kill him. That he will, if he lives to see 30, he's done pretty well. And at this point right now, he's 29. I haven't seen him in a number of years, okay? But he's still alive. He's still doing well, okay? And he has a soul, he has a spirit in him, okay? He has value as a human being because God doesn't make mistakes. In the realm of man, they might be thinking that. The reality is, God has his reasons, and how he thinks compared to how we as humans think, it's different. And I know it's not easy for them, but that's a real life example of genetics and genetic testing. Okay? Medical technologies, things like x ray machines. That's a no brainer, but that was developed in the late 1800s. Now, today, we have CT scanners, computerized tomography scanners, magnetic resonance imaging, MRI scanners. So we can start looking on the inside, not just at the bones, which is what you would see typically with x rays, but you can start seeing the guts and find out what in the world's going on. There's also ultrasound devices as well that can help a woman when she is going through the stages of pregnancy. They want to make sure that the baby is doing well, that they could find out, I don't know which week it is, but they can tell if it's going to be a boy or a girl, and they can measure its fetal heart rate. Okay, there's a lot of things involved in that medical technology has definitely benefited. We have extended the human lifespan. That is true. But the medical technology, it's not cheap. And I think pretty much every one of you know this. Okay. Now, there's also prosthetic devices. If you are missing an arm or you're missing a leg, they do have those medical technologies where you can provide prosthetic devices. And I'm pretty sure that if those people could have their arm or their leg back, they would say yes. But with the prosthetic device, it allows them to do things that they can still carry on life. Tissue engineering, okay? How about growing new skin cells to help replace burnt tissue, like skin grafts, things like that? So those fall in the category of medical technologies. We talk about DNA fingerprinting, okay? And I put up 23andMe because actually I did do it for a number of reasons. Hereditary information is pretty good. It's nearly 100% accuracy. You can't argue with the DNA, but the more DNA information that they get from people, the more they're able to put things together and come up with different things, different types of genetics for different genetic disorders, or looking at your hereditary information. Okay, um, that's just the way that it is. Hereditary information. Quick example for me. 3 out of 4 grandparents were born and raised in France. My fourth grandparent came from the next door neighbor, Luxembourg. Okay. And my mom and dad were both born and raised in France. So you'd think that I would have a high percentage of French DNA, of the French/German DNA. I'm a little over 50%. Say what? What? Exactly. I am about 20% English/Irish. And the thing is, the English DNA is on both sides, on mom and dad's side. Okay. And it's like, wait, where did this come in? They're saying, oh, this came in like your great great grandfather or something. It's like, no, you're wrong because I actually have the birth records to prove it. That they didn't come from England. I can trace my dad's ancestral line. Nobody came from England. So how in the world did that English DNA get in there? I also have Italian DNA and Spanish DNA as well. So I'm a mix, but I'm pretty much Western European. Not a big surprise. Not really a big surprise on that one. But the English was kind of like, wow, that threw me for a loop. So that's the thing about hereditary information. Now you'd think I only have one theory regarding how did the English DNA get into my line. And I have to go back in history and one line answer, most likely during the 100 Years' War between France and England, which essentially was a French Civil War. But that's another topic, another time. Now, of course, with DNA fingerprinting, you have criminal investigations. And this CSI. Who are you? Who? CSI Vegas, baby. The real crew. But the reality is, with DNA fingerprinting, it's much more. There have been criminals, okay, not criminals, but there have been people who have been wrongly imprisoned. They were released from prison based off of DNA evidence. There have been cold cases where they found the person who'd committed the crime based off of DNA evidence. So there's a lot in there. There's a lot to be said about the DNA fingerprinting. And they can get the DNA from the saliva, from the blood, from the hair. Yeah, there are ways to do it. So what does that exactly look like? What do we mean by DNA testing? Okay. So here, for example, we have a child's DNA right here in the middle, and we would expect that half of the DNA comes from mom, half of the DNA comes from dad. Okay. So what they do here with the DNA, they take the sample of DNA and then they add what are called gene splicers. Well, not splicers, but they're cutters. They're like enzymes, proteins that go and they cut DNA at certain areas of the DNA. So you're taking this DNA and you're breaking it into pieces. You put it in a little hole that's inside a gel pack, and you run electricity through it. Okay, and the idea is that the electricity pulls on this DNA, these broken chunks of DNA, from one end to the other. That's the idea. The larger pieces of DNA tend to stay at the beginning, whereas the smaller pieces end up dropping along the way, the medium-sized pieces and then the ending pieces. Okay, so that's what the DNA, when you're finding out DNA evidence, looks like. It's not talking about finding gene number 42. That's not it. Okay, they're looking at the markers that are there. Okay, so here is mom, and she has a purple color. Here's now the child has a mix of purple and magenta. Okay, so here's the question. This is a paternity test. This is a test to find out if who's the daddy? Who's your daddy? Right? Because there's a lot of issues with that. So, with that, ladies and gentlemen, if you look here under male 1 and male 2, you'll notice while male 1 and male 2 have genetic similarities, well, they're guys, okay, but there are some things that they don't share. There are differences. So when we look at the child's DNA here, here's two strands here of DNA. If we match it, you don't see it here in male number 2, but you do see it in male number 1. Now those are two markers right there. Now let's move on. Here's another part of the child's DNA. Both dads have it. Both potential males have it. All right, here's another marker of the DNA. So in this case here, okay, so far male 1 is getting 3 out of 4, male 2 is 1 out of 4 hits. So we keep going. Now you see another pair of genetic markers. Oh, look, here you go. Here's male 1 has got 2 of them exactly. Male 1 shares that same thing with male 2. Male 2 shares with male 1 and the child. Then you go down here and you're seeing 2 more markers. Oh, looky here. What do you know? It's shared. So when you're looking at it, you look at the similarities. How many of those pieces of DNA does the child and the 2 males have in common? That's how they would determine the paternity test. And when you look at it between male 1 and male 2, it turns out male number 1 is the baby daddy. And the DNA can't lie. Genetics does not lie. That's the thing about it. And that's why in 1995 with O.J. Simpson, that was the DNA testing in its early infancy stages. Okay, it was just then one of the newest things that come on the field. Today, it's a regular thing that we have. Some 25 years later, it works. Ethics. Well, bioengineering issues with sensitive issues, okay? You find out that your kid's going to have a condition, all right? Do you abort? That's a legitimate question. Do you carry on with the pregnancy or do you go and have an abortion? And yes, there have been people who made those decisions on that. What about engineering? What about improving on the original? How about, hey, I'd like to have my child have a genius IQ? Okay. Can we grow another leg to replace this young man's foot and leg? Can we? All right. How living things in nature are changed. There's ethical questions, and you have to look at the future impact as well. All right. And really, the source of all ethics, you got to look at the Bible, you got to look at God's Word. Okay? That's so important. All right, guys, this is the end of Bioengineering, Chapter 16.